Hello folks, and welcome to our next section here. We're going to be covering two different sections, or parts of two different sections today. What we're going to be calling this is equations. We're going to be looking at equations today. So we have something to warm you up and start you thinking here. What's a value such that 3 times that number in addition to 2 is equal to twice that same number, but this time you add 2, and instead of adding 2, you subtract 5? So, is there a way that we could write this using a mathematical expression? Try to figure that out. Alright, so what if we wrote this out? Is there a value such that 3 times that value, we don't know what it is, so we'll call it x, plus 2 will be equal to 2 times that value, but we're subtracting 5. So this is the equation we're looking at. 3x plus 2 is equal to 2x minus 5. Well, we can solve for this. If we subtract 2 from both sides, we get 3x is equal to 2x minus 7. And when we subtract 2x from both sides, this tells us that x is equal to negative 7. So that would be our answer, and we can check this out. 3 times negative 7, so that would be negative 21, plus 2, is that equal to negative 14 minus 5? It is. So that would be our answer. Today, as I said, we'll be dealing with equations. So what does it mean to solve an equation? Why is a solution for something like 5x plus 1 is equal to 9? Why is it 2 and not 3? Well, to solve an equation, we want both sides to be equal. Meaning that, this should be 5x minus 1. So if it's 5 times 2 minus 1, that gives us 9. If it's 5 times 3 minus 1, that does not give us 9. So remember, when we're solving, we are finding a value that makes the equation true. Now we're going to cover some properties here. These are important properties because these are actually how we do algebra. First one, we have an addition property. So what this says is, if we have two numbers that we know are equal, so if a is equal to b, then if we add a third number, so a plus c is going to be the same as b plus c. So if we add a third number to both sides, it'll stay equal. So an example, if x is equal to 12, then x plus 3 will be the same thing as 12 plus 3. Subtraction property says something similar. If we have two numbers that are the same, then we can subtract a number from both sides and it'll still be equal. So subtract the same thing from both sides, it'll still be equal. Again, if x was equal to 12, then subtracting 3 from x would be the same as subtracting 3 from 12. Multiplication property, probably can guess it. If we have two numbers that are equal, then multiplying by the same thing will mean they're still equal. So a times c will be the same thing as b times c. Again, if x is 12, then if we multiply x times 3, that's going to be the same thing as multiplying 12 times 3. Division property is the only one that's slightly different here. If we have two numbers that are equal, then we can divide by the same thing and they'll stay equal. But c cannot be equal to 0 because we can't divide by 0. That's really the only tricky part for this one. So if x is equal to 12, then saying something like x divided by 4 will be the same thing as dividing 12 by 4. All right, so how do we solve an equation? I'm going to give us 3 broad steps here. The first is expand the equation as much as possible. This would mean distribute, make sure everything is as far out as possible. Next step, solve for x or isolate x. So this is going to be all those steps for getting x by itself: subtracting, adding, multiplying, dividing, taking square roots. Then the third step, this is something, remember, you can always do in math. Check your answer. Make sure that your answer comes out to be true. So let's do some practice with some problem children. First one of those, we have something like this: x plus 1 over 2 is equal to 10. Remember, when it's something divided like this, that acts almost as a pair of parentheses around here. So instead of starting by subtracting 1, we have to multiply 2 to both sides. So this will give us x plus 1 is equal to 20, which we can then subtract 1 from to get x is equal to 19. All right, what about this one? This one is confusing because if we subtract 5 from both sides, we think this negative goes away. But if we subtract 5, it stays as a minus n. So we get minus n is equal to 5. We have a minus 1 attached to this. So that's why this one is tricky. Other way that we could do this, we could add n to the other side. So that would be the same thing as saying 5 is equal to 10 plus n. Either way, we're going to have to flip the sign on this, or we'll subtract 10. We'll find out that n is equal to negative 5. All right, for this one, we subtract the 1. So we're left with 2/3 x is equal to 10. Now, how do we get rid of this fraction out in front? How do we do this? We'd have to divide by a fraction. But dividing by a fraction, remember, is the same thing as doing keep, change, flip. So we need to multiply by the flipped fraction, multiply by the reciprocal. This will give us our answer to be x is equal to 30 over 2, which we're going to reduce to 15. And this last problem, which I'm blocking a little bit. Okay, for this one, what's the tricky part here? It's this minus sign. We need to remember that minus sign is like a negative 1, so we're going to have to distribute that into everything. That's what I mean when I say expand. So this becomes 3x minus 5x minus 1 is equal to 10. From here, it's pretty simple. We can combine those like terms, and we can add the 1 to the other side, so we get negative 2x is equal to 11, or x is equal to negative 11 over 2. Right. Now we have some practice problems for you all to do here. 6 practice problems. Go ahead and work through all of these. I'll be asking you what your answers are for each of them. All right, let's get started with this first one. What's our answer going to be? So the first thing we have to do is multiply by 2. We get negative x is equal to 20. And then we got to get rid of that negative. So we're going to divide by negative 1. That's going to give us x is equal to negative 20. So remember, we can divide by negative 1 there to get rid of that negative. For this next one, we're going to start by subtracting 1. So we're left with negative 3 over 2 is x is equal to negative 10. What do we do from here? Well, we have a fraction. We're going to multiply by the flipped fraction. So we're going to multiply by 2 over 3, and we'll bring the negative along for the ride this time. Right, so everything here will cancel out. And we're left with x on this side, and these negatives cancel out. So we're left with x is equal to 20 over 3. Right, what about for this one? We're going to start by distributing in the negative 2. This becomes 5x minus 6x minus 12. Remember that negative and the 2 get distributed to everything. This will be equal to positive 12. So we're going to add 12 to both sides. We're going to combine our like terms. So this becomes negative x is equal to 24. Then when we divide by a negative 1, this will give us x is equal to negative 24. Right, 3 more of these to go. What do we have to do for this one? Well, we have to get all of the x's to one side. So we're going to add 2x to both sides, and that'll give us 7x plus 1 is equal to minus 13. Subtract the 1, so we get 7x is equal to minus 14, which tells us x is equal to minus 2. All right, for this one, this is going to be a pain because we have both decimals and fractions. We're going to want to convert these all into either decimals or fractions. And being as I don't have a calculator on me, I'm going to convert these all to fractions. You can do it as decimals as well. So 0.25 is going to be 1/4. So we have 1/4 x plus 1/2, and that's going to be equal to 2.75. So 0.75 is going to be 3/4. And let's make this improper. So this will be 8 plus 3, so this will be 11/4. Now we're going to subtract 1/2. So we get 1/4 x is equal to 11/4 minus 1/2. And we can change that 1/2 because we're going to need to subtract it to 2/4. So if that's 2/4, we get 1/4 x is equal to 9/4. Then we're going to multiply by the reciprocal of this fraction. So 4/1. Those 4's will cancel out, and we're left with x is equal to 9. Remember, if you're ever uncertain of your answer, you can check that. So we could put this back into here, not a good one to do this with, and see whether that works out. We'll try that with problem number 6. For this one, what's the first thing we need to do? We need to distribute. We need to expand out as much as possible. So we get negative 7x is equal to 2x plus 3x minus 12. Now we're going to combine these two terms, so that becomes 5x. We have minus 7x is equal to 5x minus 12. So we can subtract that 5x, and we get minus 12x is equal to minus 12. And when we divide by negative 12, we get x is equal to 1. Right. Let's try throwing that back in to make sure our answer works. So is negative 7 times 1 equal to 2 times 1 plus 3 times 1 minus 4? Or is negative 7 equal to 2 plus 3 times negative 3? It is. We have 2 minus 9 is equal to negative 7. So that does work out. All right, that's your basic refresher on how to solve equations. Now we're going to move into something else. These are called literal equations. And this is not just your friend who says everything's literal or literally. A literal equation is an equation with multiple variables inside. So a literal equation is an equation with more than one variable. So an example would be something like A is equal to 2b plus n times m. Right? We have more than one variable in here. We'll be told to solve for one variable with that. And how we're going to do that, we're just going to act like everything else is a normal number. We're just going to act like all the variables are pretty much numbers. So for this one, we have A is equal to 3 times B times C times D. And we're trying to solve for B. So I'm going to box off B, that way we remember we're solving for it. Okay, so this is the same thing as saying we have, let's throw in some random numbers here. 3 is equal to 3 times B, and we'll say times 1 times 2. If this were the equation, what would we do? Well, we'd start off by dividing everything so that we'd get B by itself. That's what we're going to do with this literal equation. If these were just numbers, we would divide, so we're going to divide to get through here. Other way to think about that, if you have other things attached, other variables or numbers attached to what you want to get by itself, you're going to have to divide. So we would take A is equal to 3, B, C, D, and we divide by everything that we don't want on that side. So that would be 3, C, and D. Right? We'd have a C, a D, and a 3 on the top and bottom, so we can cancel those. And we'd be left with B is equal to A divided by 3, C, D. Right. What about for problem 2? Problem 2 says we have A is equal to 1/2 B times H. So this is the formula for area of a triangle. And let's solve for H. How would we do that? Well, if we box this off, we think of this as, let's say B is just 1. This would be 1/2 times 1 times H. These are attached by multiplication, so we're going to have to divide. Let's start with the 1/2. We're going to flip that and multiply by 2. So this becomes 2A is equal to b times h. Right? So we just multiply by 2 to get the 1/2 over to the other side. Now we have something kept together by multiplication. How do we get rid of multiplication? We divide. So we're going to divide both sides by b. And that would leave us with those b's canceling out. We'd have h is equal to 2a over b. Right. This next one's going to be a little bit more confusing. We're going to start by figuring out what we're trying to solve for. So we have c is equal to 5/9 f minus 32. What would we do if this were a normal problem? We'd distribute the 5/9 in. So let's do that. We get c is equal to 5/9 times f minus 32 times 5/9. I don't have a calculator with me, so I'm just going to leave that as 5 times 32 over 9. What would be the next thing we have to do? Well, to solve for f, we would need to get rid of this 5 times 32 over 9. So we need to add that over to the other side. We get c plus 5 times 32 over 9, and that'll be equal to 5/9 times f. Now how do we get f by itself? Well, we have something attached to it by multiplication. We need to get rid of this. How do we get rid of a fraction? We multiply by the reciprocal. So we're going to multiply by the reciprocal here. These would cancel out. And what would we be left with? We'd be left with f is equal to 9/5 times c plus whatever 5 times 32 is, divided by 9. And this would be our answer. So for a literal equation, all you're trying to do is get whatever variable they're asking about by itself. All right, now it is your turn to try. We're going to try one and then keep moving on once we go and solve those. So, how would you solve for x in ax plus 2y is equal to b? First thing you need to do when you have ax plus 2y is equal to b, we're trying to solve for x, so we need to get rid of this term. That's kept together by addition. So what do? We subtract it. We're left with a times x is equal to b minus 2y. All right, now we're still trying to get the x by itself. It has something that is multiplied to it. So how do we get rid of multiplication? We're going to divide. I'm going to divide everything by a, and we're left with x is equal to b minus 2y over a. Now how would we solve for n? And n over v plus m is equal to k. Right, so we're trying to solve for n. How would we do that? Well, we have this m that's over here. It's attached by addition, so we're going to need to subtract m. We're left with n over v is equal to k minus m. We've gotten rid of the m, but we still need to get rid of the v. How's the v hanging on to the n? It is being divided. So we're going to need to multiply by v to get rid of it. So what does that leave us with? That leaves us with n is equal to v times k minus m. All right, what about for this one? It's a little bit trickier. Think about how we'd get rid of that square. All right, let's start by figuring out what we need to get by itself. We need to get r by itself, so we need to get r squared by itself. How would we do that? Well, we need to get this 4 and pi out of the way. They're kept together by multiplication, so we're going to divide by 4 pi. And what we're left with is r squared is equal to s over 4 pi. Now how do we get rid of that square? We're going to take the square root. And once we take the square root, that will cancel out. We're left with r is equal to the square root of s over 4 pi. All right, one last topic for the day, which are absolute values and absolute value equations. So, as a refresher, what's an absolute value? Why is it that we say that the absolute value of negative 3 is equal to 3? This is because absolute values are distance. So absolute values are just a distance from 0. Right, so how far is negative 3 away from 0? Well, it's 3 away from 0. We can't really be a negative distance away from something. It always has to be positive. So remember, that's what an absolute value is. What are our steps for solving an absolute value equation? Our first step, you have to get the absolute value by itself. So we need to get the absolute value. In something like this example, we'd have to get rid of everything else. If it helps, you could think of this as just being its own variable that we're trying to solve for. So what would we have to do? We'd add 1 to both sides. We'd be left with 2 times the absolute value of x plus 1 is equal to, not 9, is equal to 10. Then we'd divide by 2, and we'd be left with the absolute value of x plus 1 is equal to 5. Okay, so we've got the absolute value by itself. What's our second step? We're going to write the equation out 2 times with the right side being plus or minus. I'm going to write the equation twice with plus and minus. Why do we do this? Well, we're asking what things could be a distance of 5 away from 0. So it could be that it's either going to be equal to 5 or it could be equal to negative 5. We have to look at whether this could be equal to negative 5 inside, because that would give us just 5, or positive 5. So we'd rewrite this now. We'd get x plus 1 is equal to 5, but we'd also have x plus 1 is equal to minus 5. Step 3 is going to be solve both of those equations. So we're going to solve both of those equations. What would we be left with? We'd subtract 1, we'd get x is equal to 4, and we get x is equal to negative 6. Let's double check both of those solutions. If we put in 4, we'd get 2 times 4 plus 1, so 2 times 5, or 10, minus 1 is equal to 9. That gets us our answer. What about negative 6? Well, we'd get 2 times the absolute value of negative 6 plus 1, or that would be 2 times the absolute value of negative 5. Remember, we can't have a negative value, so that would be 2 times 5 again, minus 1 is equal to 9. So that would also be good. However, one thing we have to be careful for when we're dealing with absolute values, and this will show up a little bit later in the year as well, are something called extraneous solutions. And these are extraneous solutions because they're extra. They're not worth it. An extraneous solution is a solution that's right, or a solution that you get that's not technically right. So it's a solution you get that doesn't work. We'll look at an example that has an extraneous solution if you're still a little bit confused about that. But let's get some practice in with these first. For this, what do we need to do? We need to get the absolute value by itself, so we'd subtract 5. We'd be left with x minus 2 is equal to 3. From here, we split this up into 2 equations, one with a positive 3 and one with a negative 3. We'd be left with x minus 2 is equal to negative 3, and x minus 2 is equal to 3. Add 2 to both sides, we'd get x is equal to negative 1, and x is equal to 5. Now let's do a quick check, make sure those work out. If we have negative 1, we'd have negative 1 minus 3 plus 5, or negative 1 minus 2 plus 5 is equal to 8. So negative 3, that becomes positive 3. That works out. What about for this one? Well, we'd have 5 minus 2 plus 5 is equal to 8. So we'd have 3 inside of here. That would work out. All right. What about this one? So for this one, the absolute value is already by itself. We're good to go. So we're going to split this up into 2. We'd get 2x plus 1 is equal to 3x plus 2. And we'd get another one that says 2x plus 1 is equal to negative 3x plus 2. So the negative is going to have to go to everything. Let's solve these one at a time. For this one, we're going to need to get the 2x over to the other side. So this will be 1 is equal to x plus 2, or x is equal to minus 1. Let's check that answer, make sure it works out. So is 2 times negative 1 plus 1, that's going to be hard because that's right next to the other equation. So is the absolute value of negative 2 plus 1 equal to negative 3 plus 2? So we're looking at this, we're saying is negative 1, the absolute value of that, equal to negative 1? That's not true, right? So this is something that we came to, or saw was an answer, but it doesn't work. So this is an extraneous solution. It's technically not a solution. All right, let's look at this one. For this one, we'd get 2x plus 1 is equal to negative 3x minus 2. If we put all of this in, solve for it, we'd get 5x is equal to minus 3, or x is equal to negative 3 over 5. Would this work? Well, is negative 6 over 5 plus 1 equal to negative 9 over 5 plus 2? So what would this end up being? Well, this would be, oh, I'm running out of space here. So this would be negative 1/5. Is that going to be the same, or the absolute value of that going to be the same as negative 9/5 plus 8 or 10 over 5? It is. This will be 1/5. This will be 1/5. So this is a good solution. It is not extraneous. Right, and on to this last one. We have absolute value of 5x plus 10 is equal to 5. We change that, so we solve by getting the absolute value by itself. We get 5x is equal to negative 5. Now at this point you might be tempted to say, okay, we're good to go. But let me ask you, can something ever be a distance of negative 5 from 0? No, it can't. Things will always have a positive distance. So if you get an absolute value equal to a negative number, there are no solutions. It is incorrect. All right, now I have a couple of absolute value equations for you to practice on. This will be the last two problems. Go ahead and do number 1. Okay, for number 1, what do? We start out by subtracting 1. We're left with 3 times the absolute value of x minus 2 is equal to 10. What would we do from there? Well, we divide by 3. So this would become absolute value of x minus 2 is equal to 10 over 3. What do we do from here? We split this into two equations. This becomes x minus 2 is equal to positive 10 over 3, and we'd have a negative 10 over 3. We would add 2 to both these sides, so we would get x is equal to 10 thirds plus 2 is the same thing as 6 over 3, right? Multiply both of those by 3 over 3. And so this would give us x is equal to 16 over 3. Then for the other one, we would add that, so we'd get x is equal to negative 10 over 3 plus 6 over 3. And that would leave us with x is equal to negative 4 over 3. Those would be your two answers. Right, let's look at this one. We have absolute value of 5x is equal to 2x plus 1. Be careful, this may have an extraneous solution. All right, so this absolute value is by itself, meaning we're going to split this up. We'll have a 2x plus 1 on one side, and we will have all the way over here a negative 2x minus 1 on one side. So we get 5x is equal to 2x plus 1, and we get 5x is equal to negative 2x plus 1. What are we going to do? We're going to subtract 2x. So this becomes 3x is equal to 1, or x is equal to 1/3. And so now let's put this back in, see that that works out. Is the absolute value of 5/3 equal to 2/3 plus 1? Yes, it is. This will be 2/3 plus 3/3, so that is good to go. Let's check the other one now. We get 5x is equal to negative 2x minus 1. So we're going to add the 2x. That becomes 7x is equal to minus 1, or x is equal to minus 1/7. Let's check that one out. Is that correct? So, is the absolute value of negative 5/7 equal to negative 2/7 plus 1? So, 1 is the same thing as 7/7. This right side, or this left side becomes 5/7, and is 5/7 equal to negative 2/7 plus 7/7? It is. So both of these answers are correct. There are no extraneous solutions for this. All right, that caps it off for this lesson. If you have any questions, make sure you're asking me over email or coming to office hours.